Okay, we're good. Okay. I'm gonna pull up the applet too. Let's see.
Oh yeah.
Okay. So for number 3, I just put in that z-score and then filled in the shaded part on the left and the right of the curve.
Hmm.
Is that what you did?
Yeah, I think that's one of like the few quiz answers I did.
I know, me too. So I got 0.175.
Let me pull it up. I think I got the same thing. That sounds familiar.
Okay.
Meeting quiz. My stuff is taking forever to load right now. I don't know if it's my internet.
That's fine. I'm not in any hurry. I don't have anything to do this morning, so I'm good.
Okay. Oh yeah, so I put 0.1745, but we're supposed to round it, huh?
It says the 3 decimals. So is it 0.175 or is it
Hmm.
okay?
Yeah.
Okay.
Okay.
Number. I was just looking at flights to for random. It like from Phoenix to Salt Lake, it's only $20.
Dang.
I know, but of course, it's not when I need flights. So that's up.
Yeah.
Okay, sorry, I got distracted for a
You're
second.
okay.
Number 4, I thought it could not be determined from the information given, but I wasn't sure about that.
Yeah, that one I was kind of not sure on.
A smaller standard deviation. And I kept going back to the text, and it didn't really like specifically say anything about it.
Yeah. Yeah.
So, because don't you have to have some sort of information?
I feel like it, yeah, like when I was looking at it, I didn't really, yeah, I didn't get it. So I figured it had to be, it can't be determined because I kept looking and looking and like control F like on documents and stuff. I didn't see
Right,
it.
right. Okay. All right. Well, I'm gonna leave that one. Number 5, I put the central limit theorem. Is
Yeah.
that what you got? Okay. All right. So these ones I kind of did, but I'm not sure if they're right. So, like, so I got the z-score of 1.045.
1.045.
Uh-huh. But I don't know. I guess we can put in the answers and then check them and see if they're right. And if they're not, figure out what it is. But I just did like the 160 minus 150.8 over the standard deviation.
Yeah, that's what we're supposed to do, right? It's
Yeah,
the number minus the mean over the standard deviations.
right.
If that's what you got, I trust it.
Okay. That's how I did it. So, and then 7, for number 7, I just put that z-score into the applet
Mm-hmm.
and selected the area to the right of the z-score.
Yeah.
Okay, so I got 0.148.
Okay.
Okay, number 8. So for that one, I got the same z-score. I got 1.045. So this was one I wasn't sure on. So maybe we can. I added all the sample means up, or the sample scores, and then took the mean of that,
Yeah.
and then got the x, and then I divided that. Subtracted that from the mean. So I don't know if that's the right way to go about it or not. I feel like I wasn't sure because when you get a sample, you have to get their sample mean, right?
Yeah. Wait, what did you subtract from the mean?
So I added up the scores and then divided it by 5, and then I got 160 as the sample mean.
Mm-hmm.
And then I just subtracted the 160 from the mean that they give us in the problem, the 150.8. Hold on. Gabriel's joining us. Let me send him this link real quick. Okay. Maybe he'll know how to. But I just hate getting the same answer that I get in another question because I feel like that.
Yeah.
So, but that was the only way I could figure it out. Okay, sample rate number. What's the z-score?
We don't have to divide by the standard deviation or anything like that?
I did, yeah. So I did the 160, which was the sample mean, minus the 150.8, which is the one they gave us in the question, and then divided it by the sample deviation, or by the standard deviation, the 8.8.
Okay. So that sounds right to me. I don't know. I just get really confused, like especially with the way they word problems. Like I hate it.
Yeah. I took a economics class last semester, and I wanted to throw my book out the door every day. That was the hardest class I've ever taken.
Oh.
This is so hard. And it's just the wording of the questions, and then like going back and forth with the text, it doesn't make sense. I'm like, I understand you want us to infer some of this stuff, but you're supposed to also be teaching us.
Yeah, exactly.
I was so frustrated last semester. Okay, so I got 1.045. Good morning.
Hello, good morning.
Morning, Gabriel.
How are you?
Good. How are you?
Fine, thank you. Okay, Zachary is not coming today, right?
No, he said his internet was down.
Okay. Are you in the quiz now?
Yeah, we are. We're just talking about question 8, but we'll go back. We can go back through the first couple ones with you. Make sure we.
Okay, please.
Okay. Let's see. We'll start with number 3. You got 0.175.
Okay, 0.175.
Yeah.
You're using the applet, right?
Uh-huh.
Okay. And the second one, the number 4?
We didn't think it could be determined from the information given, but we weren't sure on that one.
Okay. Okay. And number 5?
The central limit theorem.
Yes, I agree with that one too. Okay.
Number 6, 1.045.
Okay.
Number 7, 0.148.
How do you get the answer?
Okay, these were ones we weren't sure on. So if you, okay, so number 7, for this one, I put the z-score that we got in number 6 into
Okay.
the applet, and then I selected the area to the right of the z-score.
Okay. Number 7. Okay.
And then number 8, this is the one we were just talking about, number 8. We added up the scores and then took the mean of those
Mhm.
and then used that to find the z-score, and we got 1.045.
Okay. Number 4.
And then number 9, I just put that z-score. I haven't done it yet. 1.045 into the applet, and then just selected the what did they want? Greater than. Okay, 0.1480 for number 9, because they want 4 decimal places.
1.840.
1480, yeah. Oh, they lost him.
No.
Hopefully. He did that last time too, so hopefully he'll come back.
Okay.
Okay. So does that sound right?
Was that number 7 you guys were looking at?
Number 8, the one that we were talking about before you came on. I feel like it's kind of a culmination of everything we've learned up to here, because didn't we have to find sample means before?
Yeah.
So I feel like we had to use that to get to this, and then it's kind of building on it, but I don't know. I'm okay like submitting it and seeing what happens after we get through the rest of these.
Honestly, I'm the same way. I was trying to figure out 10.
Okay. No.
But yeah, I'm good with 8. I think that sounds right. Well, you got 1.045 is what you said, right?
Yeah, 1.045, and then 9 is 0.1480.
148.
Yeah, they want 4 decimal places.
Okay.
Yeah. And then for number 10, I got approximately normal, but I don't think that's right. That now that I'm reading the problem again. Okay. Oh, wait, it is because there was a large number of students selected.
Mm-hmm.
So because of that, what was it? The central limit theorem,
Mm-hmm.
it has to be greater than 30, and then the sample size, the shape will be normal.
Okay. Perfect.
Right, Gabriel? Is that what you?
Yes, I think the same.
Okay. Okay, the next three I didn't do, so we're just gonna have to. I was reading them. I was like, I don't understand. So.
We have to, on the 11, we have to find the mean, and 12, the standard deviation.
So how do you find the mean of the distribution of samples?
Let's see.
Okay, so we know the mean is 3.5. That's like the parent population, right?
Okay.
Mm-hmm.
And then the standard deviation of the parent population is 0.7, and n equals 81. Okay. What is the mean? Okay, so I think it's 3.5 for 11.
Okay.
Because isn't the mean of the parent population also the mean of the sample?
Okay. 3.5.
I think. I don't know. I think that's
Yes, maybe because we have to round the answer to 1 decimal place. Yes.
I think. Yeah. Okay. And then the standard deviation is going to be hold on, since the parent population know the same condition, normal. So it's going to be the 0.7 over the square root of 81 is going to be the sample. I think standard deviation for them. I think. Let's see. So 0.7. So I got the standard deviation as 0.07 8.
Okay, I'm lost.
Is that how you would figure that out?
What did you do again?
I took the mean, or I'm sorry, I took the standard deviation of the parent population,
Mm-hmm.
divided it by the square root of the sample size of 81.
That sounds right. Let me look at the.
Yeah, okay. So okay. So it's on section 2 of the text, like the review of sampling distributions.
Yeah, I think that's right.
Is that how you would do it?
Mm-hmm. What did you get?
0.078.
Okay.
Question 13.
Yeah, that was for question 12.
Oh, that was for 12?
Yeah, sorry.
What was 11?
3.5.
Okay.
What is it probably?
Less than 3. Okay, so that question right there is making me wonder if question 11's answer is 3.3.
For what?
Number 13,
Okay.
because they're asking if it's less than 3.3. So
Yeah.
probably 81. I know there's a way to do that.
So do we have to do the value minus the mean over the standard deviation?
Oh,
Value? No, I don't think that's right.
no, I think you are right. 3.3 minus 3.5 over the standard deviation.
See, that's what I don't understand, the way they word questions. Like, how are we figuring out if it's going to be less? Like, are we doing it right by just putting the value in? Because, or does that give us, yeah, that gives us the z-score, and then we put it in the applet, and then, right?
I think, yeah, I think you're right. Yeah.
Okay.
That sounds right. So 3.3.
My calculator.
So I got negative 0.2857.
What was the mean for this?
The mean was 3.5. And then they want to know less than 3.3. So I got 0. Okay, so when I put that answer, when I put the negative 2857 into the applet, I got the probability is 3874, like 0.3874. But they only want 3 decimals, so 0.387.
With the minus or without the minus?
Without the minus.
Okay.
Sorry, what did you get for the z-score?
The z-score I got negative 0.2857. Is that what you
Okay,
got?
yeah, that's what I got.
Okay.
And then when you put it in the applet, what did the area to the left of it say?
The area of the left said 0.3874.
Sorry, alarm. 0.374?
387. Okay, and then they want to know greater than 3.3. So that's going to be 0.613.
0.613.
Uh-huh. Yeah, 613. For number 15, I did what we did for number 13. Like I subtracted.
Okay, and what did you get?
I got 0.053.
Okay.
So I'm gonna submit this and see how we did. Fingers crossed.
Okay.
Okay, let's see. Okay, so number 4 is wrong. Number 5 is wrong. Oh, 8, 9. Oh, man. All right, so let's see which was wrong here. Number 4 is wrong. Number 5 is wrong. Number 8, number 9, number 13, and number 14.
Wow. What was your score?
64%. So that stinks.
Ugh.
Okay, let's see.
We have the exam the next week, right?
Yeah.
Wow.
You know if it's is it open book, like open note or anything?
I think
Oh,
it's
I hope so.
maybe.
Okay, so number 4 was wrong. I'm just writing down number 5 was wrong. Dang it. 6. God, that really stinks. 7.
So it was 4, 5, and what?
4, 5, 8, 9. Sorry, I'm just writing these down here. Bless you.
Let's see.
Number 13 was wrong. 14 was wrong. And that was it. So we missed 1, 2, 3, 4, 5.
You said 14?
Yeah, 14 was wrong. But 15 was right.
Mm-hmm.
Okay, that stinks. Let's see. Okay, number 4. So, which will have the following smaller standard deviation if 9 observations are randomly drawn? See, I don't understand that question. Number 4.
Let me go back. Yeah, I don't get that one either. I just figured I would try with this second answer, and if I get that one wrong, then we know it's the first answer.
Okay, that sounds good.
Oh, this is so bad.
Let's see. I don't understand that question. Nine. Okay, I'm like thinking about it if 9, okay, so the distribution of the individual samples, they could be all over, but then the sample mean, I don't know. I don't know. I have no idea. All right, I like your plan to just guess and then we'll know.
Mm-hmm.
Okay, so number 5. See, I thought that was the central limit theorem. I really did.
Okay, but I just got the same thing for question number 8, like after I worked through it all
You did?
myself, yeah. Because it's those 5 numbers divided by 5 to get the sample mean is 160
Right.
minus the whatever mean, 150 something, divided by the 8.8.
Yeah.
So I don't know.
I don't know. I don't know.
Ugh.
I don't know, because that was the only way I could figure out how to do that one. Okay, Diane. Let's see. Times two. What, do you remember what lesson that was for, let me see what. I was just trying to go back to see if,
I don't know what else to do. I'm trying to go back to like figure out, maybe we did something wrong calculating the sample mean, but that doesn't. Okay, the mean of the sample mean is U. So does that mean that it would be the 150.8? So in lesson 6, it says Mm-hmm.
the following facts are always true. The mean of the sample mean is U. So that would be 150.8. And the standard deviation of the sample mean is the standard deviation divided or over the square root of n. So
I found the answers for question 4 and 5.
oh, okay.
For question 4 is the second option.
Okay.
The distribution of the sample means x. And for question 5, the answer is the law of large numbers.
Okay. Thank you.
Okay, feedback.
Where did you find the answer to question 4?
I just submit my quiz with different,
Okay.
different answers.
Okay, perfect.
Hope it works.
Okay, thank you.
You're welcome.
Okay, so what were you saying, Jordan, about the 150?
Okay, so in the text it says the mean of the sample means is U. So I'm wondering if it's that 150.8. Because it doesn't make any sense that that would be the right answer, but that's what, okay. The following facts are always true. They do not depend on the central limit theorem. They do not depend on sample size. These facts hold for the sample mean X of any simple random sample of size N drawn from a population with mean U and standard deviation. The mean of the sample means is U. So that to me is saying it would be 150.8.
As the answer?
Yeah.
Okay.
It just doesn't make sense, but I'm wondering if they were throwing.
But that's the z-score. It's asking for a z-score. Is that
Well, and then to do, okay, so then the standard deviation of the sample means is it will be the 8.8. Okay, hold on, let's see. Hold on. 1 square root of 5. Okay, so 2.236 over 8.8. Okay, so 8.8 divided by 2.236. Yeah, that doesn't make any sense because I'm getting the standard deviation if you do it. Like that is 3.93. And I don't think that's, well, maybe that is right. Hold on. I thought it can be more than 1 though. Yeah, that doesn't make any sense. Because then we get like an itty tiny bitty number, like 4.1425 to the negative 5.
Mm-hmm.
That can't be right. Eight, 9, 7. Okay, number 9. What is that?
And then it's like we can't really do 9 until we have 8.
I know. I really think it's 150.8.
And that's the z-score?
No, that's the no, that's the sample mean. Okay, so the z-score. We already did that. We did that though. If we took what we got the sample score minus the 150.8, that's what we did, right?
Yeah, 160.
And that wasn't right?
Uh-huh. Stupid cat is in the house. Spooky, get out. It's our neighbor's cat.
Oh, nice.
I'm super spooky, sorry. Spooky, you know I don't like to touch you. Get out. Spooky. Out.
Is the z score the sample? Is the z-score? No, the standard deviation or no? Now I'm getting all my terms messed up because I'm so confused.
Excuse me.
Thought I heard the bell jingling, and then I heard him meow, and I was like, ugh. I wonder how long he's been in here. Stupid.
I I'm so frustrated right now.
And it wasn't a rounding error that we did or anything? Because, I mean, everything else seemed right, so I don't...
Okay, so the z-score equals x minus u over the standard deviation, and we did that.
Did we calculate x right, the sample mean, by just adding them and dividing?
See, that may be, but isn't that how you get?
I thought, yeah.
Okay, so let me see. Okay, well, maybe we did do it. Okay. So, okay, so in lesson 4, we had to create a table
Yeah.
to find the sample mean. So I wonder if that's, okay, I'm gonna, so let's see, we have, and then we have 1/5. Okay, so we have 60. Okay, so okay, so let's see, 32 plus 30. Okay, so when I took so I took those 5 values and then I did it times 0.2. There's 5 of them, so if you take, it's like 1/5. So 160 times 1/5 equals 32 for the first one, and then I just did all of that, and then I added up those numbers. I'm thinking that the mean for those is 160. But isn't that?
That's what we got.
Is that what we got?
Yeah, we did 160 minus 150 point.
That's.
Yup.
And I mean, that's that column that we were supposed to do. So, Calculate the population standardization odds. I don't understand. I don't know. I really don't know.
Yeah.
Okay.
I think I got 13, but it's probably wrong.
13 for which one?
I got a number 13.
Oh, you did? Okay. What did you get?
I got 0.4207. What would 0.421, right?
4.21. Yeah. Okay. How did you get that one?
So I did 3.5
Mm-hmm.
minus 3.3 divided by, what was the standard deviation?
Like point.
Oh wait, that's wrong. I didn't divide it by standard deviation. Never mind. Point 7. What did you get for 13 and it was wrong?
Hold on 1 second.
It was 0.387.
That's what I just got. I quit. I don't think it's possible for Jordan to be wrong. I think there's a mistake with the quiz.
I agree. I don't know. I don't know. Are we like looking too much into it and it's like, are we reading too much into it and the answer's right in front of us?
I don't know. Hang on, someone's calling me.
Okay.
Hello? What was that?
Okay, girls, I have to
Oh,
go.
David, yeah, I was at work. I was at China Garden, but when I got off.
And
Okay.
I'll see you the next week, okay?
No, on Wednesdays I
Yeah,
listen
sounds
to
good.
it.
I will email you once I get this all figured out.
Please. Yes, because if you redo the questions number 4 and 5, you can have a 76.47%. That's a
Okay.
great result. But
Yeah.
I'm going to study more because I don't really understand very much about this lesson. So sorry for that.
No, that's okay. And we were talking about that before you came too. It was hard for me too. I wasn't getting it either. So yeah, we'll try and figure it out and we'll let you know.
Okay, thank you very much. Have a good week.
Good day. Have a good weekend.
Bye.
Bye. I know. That's how I felt last night, and I was finally like, I don't get it. I'm done.
I quit.
It's got to be like, okay. It's got to be so obvious that it's. sample of 5 students was selected to take the GRE. Their scores are. What is the z-score corresponding to the sample mean? All right. Okay, I'm going to add these up one more time. 160. 160 minus 150.8 divided by 1.045, and that was wrong. I don't even know. We have to be missing, like, we're missing something, but what is it? That's, okay, let's try this. Okay, 160. Okay, 150.8 minus. I'm trying something different that I haven't tried yet. So,
Okay.
I don't think I've tried this. Okay, so 8 divided by 6. Okay, when I do, so I did what we did in number 15. I took the 150.8 minus 160 divided by the standard deviation over the square root of the sample size, which was 5. And I got negative 2.337. But can the z-score be a negative 2.337? I feel like,
I don't know. I think it can. Try plugging it in.
yeah, I did. Okay, so it can. It just gives you a really small area. But that's the only other way that I could figure out how to do that problem.
Mm-hmm.
So we can try it and see if that number works.
Yeah, let's try that because I don't know what else to do at this point.
Okay, so, but is it, okay. Let me just, yeah, okay, so, Okay, so for number 8, try negative 2.337. It doesn't feel, that just doesn't feel right.
Negative?
Yeah. But I don't know. That's what I'm, is it?
I don't know.
How do you get the okay. How do you get the Z score of just the sample data? Maybe that's,
I don't know.
that's a good idea.
Yeah,
That's a good idea.
I pulled one up, but there's no sound. I need to-
Okay, so we found the population mean of a data set. We did that, right? Find the population standard deviation for the data set. So the square root of okay, so you can have a negative Z score.
Mhm.
Like I just pulled up this like statistics calculator and it gave an example of it, kind of like what we're doing everything right.
Yeah.
So let's try that negative 2.337 and see what happens. What is the probability? Okay, so
What
that
number was that?
so the next one, if we use that number, the probability is 0.0097. So 0.010. How many decimals do they want it to? They want 4 decimals. Okay, so it would be 0.0097.
For number 9?
Yeah.
0.0097?
Uh-huh. And that almost makes me wonder if that's right, because they always have you do 3 decimal places, but this one they're having you do 4.
Oh, yeah.
Again, I'm reading into things because I'm like looking for it to be right.
Yeah.
Okay. 11. 11 was right. 12 was right. Okay. What's the probability that the mean GPA for 81 be less than 3?
Oh, this is the one I redid and got the same answer as you.
Okay, so we need to figure out the z-score, right? That's like step one. So will be less than 3.3. Okay, so we take 3.5 minus 3.3. Do you remember if there was anything? I remember reading something about that, like where you had to subtract, like to get when it's in between.
Like when you subtract the means and then before
Yeah.
you divide it by standard deviation? Or?
It was like one of the example problems, I think.
Oh, I don't know.
Okay, so we got the z-score as 0.286. 0.286. And they want to know, but is that, okay, so is that the z-score for 3.3 or is that the value minus the mean? So 3.3 minus the mean, 3.5 over standard deviation, which is 0.7 divided by the square root of 81. Is that what we did?
No, I didn't divide it by the square root of 81. I just did it again and I got the same thing.
Okay.
0.387.
0.
I divided it by the standard deviation, I think.
Okay, so 0.7 divided by 9 equals 0.0778. 0.2. Oops. 0.2. Okay, so I got negative 2.571.
As
Again,
the
that's
answer?
such a weird number.
That was the answer you got, or that was the z-score?
That's the z-score. So that's such a weird number.
Yeah.
Okay, and then they want to know what would be less than.
Mm-hmm.
So 0.0051. So 0.005.
Okay. Let's try it.
Then greater than the 3.3. 0.995. All right, you want to give that a go and see?
Yeah. It was 0.005.
Uh-huh.
And then
.995.
Oh, wait a minute. 0.005 is 13, right?
Yeah. Uh-huh.
And then 0.995 for.
Yeah, for 14.
Okay. And for 15, we got 0.053, right?
Yeah. Mm-hmm.
Okay. And then 12 was 0.078,
Yeah.
11, 3.5,
Yep.
and then 10, approximately normal.
Yeah.
9.0097,
Yeah.
and 8, negative 8.227.
Negative 2.337.
I don't know how I did that.
It's because we've been working at this for an hour.
I know. Negative 2 what?
Negative 2.337. I don't think that's right. That just doesn't make any sense, but
Okay. All right, and then 7 is 0.148,
yeah.
and 6 is 1.045.
Yeah.
5 is the law of large numbers.
Yep.
4 is distribution of sample means.
Yep.
3 is 0.175.
Yep.
2 is true. Oh, duh. 1 and 2. Okay, let me submit. I'm scared.
I know.
8 is wrong. But hey, that's it. Only 8 is wrong. Yeah.
Yes.
Oh my gosh, Jordan, good job.
Woo! No way. We totally did that together. Okay. So,
Yay.
oh my gosh, that is so weird. Ugh.
I would say for that one to just take a look at the others and see what they get,
Yeah.
you know?
Yeah. I can't
And
believe that some of those are right.
Yeah, I know.
Like, I feel like I had to stretch it to make it different. So how?
Yeah, I know what you mean because like the first thing that came to our mind, we'd try it like the equation or whatever, and then we got the wrong thing. So it's like I don't know, it's like forced.
Yeah, yeah. And it shouldn't be like it should be because it's like math. It should be like black and white. And
Yeah.
oh, all right. Well, that makes me feel better. At least it's only one now.
Yeah, thank goodness.
Okay. Well, I will try and work on this later and see. And that was a good suggestion to go look at the other.
Yeah, I didn't think of that before, but now I'm like, hey.
Yeah, that's a good idea and figure out if they can figure it out. Because I don't know what else we can do.
Mm-hmm.
Okay, cool. All right. Well,
Thanks so much, Jordan. I'll talk to you if I find it too. I'll let you
yeah,
know.
okay. Sounds good. Well, have a good weekend.
All right, you too. Thanks. Sorry, I'm not on the camera.
Oh, no, you're totally fine. We will see you on Tuesday.
Yes.
All right. Have a good weekend.
All right, you too. Thanks. Bye.
Bye.